All right, so we gotta go on with this problem. Um, yeah, this is a partition labels problem. You are given a string S. We want to partition the string into as many parts as possible so that each letter appears at inmost one part. For example, string like ABCC can be partitioned into ABAB and CC. But partitions such as ABA, BCC, or ABCC are invalid. Note that the partition is done so that after concentrating all the parts in order, concatenating all parts in order, the result string should be S. So that's obviously true. Uh, Here we initialized a map of counts and then we fill them. For each letter, we're gonna keep count how many times they appear in the string. Then we created a new map char set which does the same thing but for each partition. We also initialized a new variable start which quite literally indicates the start of a um, start of this partition, and then we're just gonna iterate over the S. How do we know that? Um, how do we know that we don't need the next partition? Uh, we need it. We come up with like this. We set needed variable as true, and then we iterate over the char set, which is count inside, or should I just make it part count? Uh, Part count is more suitable. Is a more suitable part count. Part counts. Part counts. Uh, Second. Part counts. Uh, Part counts s plus 1 plus plus. Part count clear. Result size equals 0. Result pushback. Part counts. I think that's it. Start would be reinitialized as this is the start of the next thing, and I minus start will be pushed as a length of our partition. What do we do if we need the next partition? Well, this just continues our for loop, just jumps over those lines and goes on to execute the next iteration of this for loop. Return result, and in the end we obviously return result. We should run this code in order to understand what the hell is even going on. Both or char set here, obviously part counts makes more sense. Part counts 9 was added for some reason. All right, I think what we should do here is to see out essentially where are we in the code, in the loop over here. And run again, and let's see what the hell is going on in our code. So I is 0. Obviously, here we have no partitions. Um, 1, obviously, like we have a 1 character, then we have 2 characters, then we iterate our 3 characters, AA. Now we have AABC, da, 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 da. Here, I think at the mark of 10, we probably started a new thing, you know, 10, 12, we have a newer one, like at 17, we have a new mark, but we do have a new mark, but it didn't get pushed for some reason. Why would this not get pushed? Oh, this is why. This is why it didn't get pushed. I see. I see. I see the bug here. Here is just else. Here is just, well, start would be 0 here, so why not? Yeah, why not? Get rid of this, get rid of this, and do that. I think this should change. I think we should make it better. Yes, we have an accept. After 1 year of, after 1 hour of, 1 hour of, after an hour of grind, we have some sort of result. Now I think we should just comment out the lines over here. Comment out, comment out. Don't need to see out because we're not noobs. And we should submit and we should see what's going on. I think it should pass because, yeah, yes, we passed. It was pretty, there was no tricks, you know, this was like a very straightforward problem. There was no tricks. This is why we actually passed. Let's grab DP. Where are we? Grab greedy. Whew. Stop. I would love to find a way to pause streaming, but alright, whatever. It is what it is. Valid parenthesis string. Let's just solve a new problem, new day. Let's just solve it and we'll be good, I guess. Math and geometry, image. I want to solve 2 other problems for today. I'm not good at hard graph problems or 2D DP problems. And obviously I want to become better at them at some point, but today it's gonna be 2 more problems and that's it. Greedy, valid parenthesis, string. Let's go. Let's fucking go. Valid parenthesis. Parentheses. Let me check the phone real quick. Yeah. life sucks, but life is too short, and we have to do Leetcode. Life is very short. You have to do as many Leetcode problems as you can. Given a string containing only 3 types of characters, return true if S is valid. Left parenthesis must have a corresponding right parenthesis. Any right parenthesis must have a corresponding left parenthesis. A left parenthesis must go before the corresponding right parenthesis, and star could be treated as a single right parenthesis or a single left parenthesis or an empty string. Wow, an empty string. So S can be essentially anything, right? It works for us if we need it to be. It is gonna be solved using a fucking stack. Hint. Use backtracking to explore all possible combinations of treating star as either this or that or an empty string. If any combination leads to a valid string, return true. Oh, this is a good one. This is a good one. So we have a string, right? And the stars can be in like first position, third position, whatever. Basically, stars are sprinkled into our string, and we just need to explore each case. You know, is it a? We have 3 options in each whatever, in each star. It can be left, right, or just empty, and we have basically 3 options to do. 3 options to choose from at each star, and like you could probably see these as a tri tree, where we have like 3 legs, like a tree has 3 connections outgoing from a single node. Into is dpij represents whether substring ij is valid. dp, so this is dynamic programming problem also. In 3, keep track of the count of open paren and count so far. If you encounter the closed paren, it should balance with an open paren. Utilize a stack to handle this effectively. So whenever we see a left par, we push the stack, and whenever we see right par, we pop from it. I think this is the logic. How about using 2 stacks instead of 1? Think about it. Wait, what? Why the hell should I need 2 stacks here? 2 stacks. 2 stacks. I don't get this, but let's try to code it up. So combinations, like let's just return false. But before that, we must generate like all strings that are just part of all possible strings, right? So generate all. Just call this generate bool, like a vector of strings all generate parse and s. Obviously, what we're gonna do is for string string all, we just see out s and now we have to implement void. No, not void. Vector string generate parse from string s. Obviously, we should have this generate star string s and this should be like a recursive function, right? This should be like a recursive function. No. This should be taken as a void, as an argument. Result. Yeah, like if and we should do this really. Yes, I think that works just fine. I think that works just fine. I think it works just fine. Yeah. So we have generated, probably generated, sorry. Test case. Um let's do that because, and let's run again. For single stuff it works, but yeah. Yeah, this is open. Yeah, yeah. This so far so good. Here, so far so good. And here also, I think, so far so good. Yeah. Yeah. So we have generated, so we are here, right? Is backtracking to explore all possible combinations of treating this as either to string. If any combination leads to valid string, return true. Now we just have to know if the given string is valid. You know, yeah, like we have to iterate over this. If any of those strings are actually valid, then we can go home, so to say. Then we can basically. Oof. dpij represents whether the substring ij is valid from I to j. Yeah, I think we are probably going to have like n by n grid or n 2D array, right? Like, 2D array, which basically tells us if some if that string is valid. And why should we need this? Keep track of the count of open parentheses encounters so far. If you encounter close parentheses, it should balance with an open parenthesis. Utilize a stack to handle this effectively. How about two stacks? Um, two stacks to handle this effectively. So basically one stack would be for an open. And then I don't know what to do next. I just don't know what to do next. I have to find if they are valid. I think there should be like a simpler problems. Similar questions. Parenthesis string can be valid. What's that about? A parenthesis string is a non-empty string consisting of left and right. If valid, any of the following conditions is true. What? What's that? It is that can be written as AB, A concatenated with B, where A and B are valid parentheses strings. Oh, AB. It can be written as A, all right. You are given a parenthesis string as this is an important. This is a pretty cool problem also, but let's just stick to this. I just don't get the DP part of it, you know? I really don't get the DP part of this problem. Topics, dynamic programming. Yeah, I don't get. Okay, let's initialize a stack. Like, let's say int. Who cares? Stack. Who cares? And we will be iterating through all the chars in S. So if equals that, push 0. Oh, what have I done? Else if the C equals closing bracket and empty pop top and no, just pop else. This means that just continue. Break the for loop, because just break for loop. To go to the next iteration of strings. Break will be like to break out of a for loop in C++. The break statement is used when a card inside a break immediately determines the loop's execution conversions to the statement following the loop. So this will break. And shit, I think we need an int. And so if that is achieved, what we need to do, return true. That's it. Probably that's it. St push just what? Pop. Push back. This was a problem, you know. Else, what's that? I think I solved this. Probably it's fast enough. Probably it is fast enough. Wrong answer. What the hell? What the helly? Yeah. And yeah, I think else break. Another wrong problem. Come on. What? Oh no, we only have this all is just yes. Will this solve it? Would this solve it? No, this is just wrong. All push back. Yes. No. What's wrong though? Why didn't it come here? Shit. I messed up pretty good, didn't I? Messed up pretty good. Pretty damn good. Oof, it's goddamn hot here. Yeah. What's so it was a memory limit. It's not often that we get memory limit, you know. It's not often. Maybe instead of saving it, I should just, you know, yeah, instead of saving all this into a some sort of Yes. All right. I'll save this code and now into refactor. We probably need to do this. And instead of generate stars, we should get rid of result pushes. We should check valid here. Check valid like this. Valid like this. And yeah, just get rid of that probably. Get rid of this probably, yeah. Yeah, just get rid of that entirely. And here, do the checking. I should do the checking. Yeah, like this, you know. No, false. No, don't return false here just yet. I don't know where to return false. Here? Oh, this is. I feel like this is very bad. I feel like this is just a bad thing. And this is just undefined behavior. This is just God knows what's going on here. Addition of unsigned offset to. Yeah, at this point, God knows what's going on in this code. You know, really. Damn. Yeah, I'll just come up with a new solution. I'll just read through the solutions now, I guess. Left mean and left max.
before we get into the code, I just want to show you another way that our system could have been invalid. Suppose our string has two quotes, parentheses, and then two open. Of course, our left min is never going to be negative because if it becomes negative, we set it back to 0. But if our left max does become negative, in this case, it would be -2 from this after we see these two. That's how you know we can return false. It will never be valid. We'll never recover from this. The maximum number of leftover parentheses you have is negative. That means there's no choice that you can possibly do to make this valid. Okay, so before we get into code, as you can tell from this algorithm, we don't even need any extra space. So the space needs to go 0, and we only need to scan through the string once. So the time needs to go again. So now let's code it up. Okay, so now let's code it up, and like I said, it's going to be variables left min and left max initially are both going to be 0, and then we're just going to go through every single character in this string. If we get a open parentheses, a left open parentheses, we're going to increment both of our variables, left min and left max are going to be because here we don't really have any choices. We have to increment the count by 1. And in the opposite case, where we do have a open parentheses, we also don't have a choice, so I'm going to copy and paste this. But in that case, we're going to be decrementing the count by 1. And the else case is when we have a wildcard, we specify that character. And this is the part where we do have a choice. So I'll copy and paste it again, but with the left min, we're going to decrement that count, that we have a closing parentheses. And if we choose the wildcard to be open parentheses, we're going to increment the left max by 1. But remember, if the left max ever is negative, that means it's impossible for our parentheses to be valid. So in that case, we're going to but left is negative. We're not necessarily going to return our left max is not negative.
All right, so I read the write-up, and there's a smart trick that is used to solve this problem. So we start by having two variables, left min and left max. Left min is going to represent the minimum amount of left parentheses that we can have, and left max is the maximum amount of parentheses that we can have. If left max ever turns negative, this means while iterating the string, this means that it cannot be fixed. This means that our right parentheses have been way more at the point of iteration, and it cannot be fixed. This means that we basically have a lot of right parentheses to our left, and whatever we do here, it's just unfixable, right? So let's go on with solving this. So we obviously put in s we iterate over here. So if c equals open parentheses, we should increment both left mean and left max. Else if c is equal to closing parentheses, like both of those should get decremented, because like sort of like the stack gets because we like this count like technically just counts the size of a stack. Yeah, the size of a stack. Size of stacks. We have 2 stacks. I understand why it's at 2 stacks now. This is like the minimum. One stack is minimum number of parentheses, and the right stack is like, or another stack is like maximum number of left parentheses. So like else, if it's a star, we should have like the minimum should get decreased. Like this is an option that we chose star to be a right parent, and left max should increment, because this is a case where we just chose the star to be left one. Obviously we can choose an empty string, and this is why it's called min and max. There could potentially be some numbers in between, but who cares at this point? We don't care about this at this point. Alright, left gets the min gets decremented, max gets incremented, and we have another thing, like if left max becomes less than 0, this means we chose extra right parentheses at some point. So which cannot be fixed. Right parentheses cannot come before left parentheses, and we should just return false. And left mean, if left mean ever becomes less than 0, left mean like a minimum number of 0. Like we should keep it. Why should we keep it? Yeah, I don't understand this. Why should we keep it 0? Hmm. Why should we keep this thing 0? Like, let's say this is the beginning of a string and we start by right parentheses. And like left min just became -1. Why should we like magically turn it back to 0? I don't get this. I don't get this. And like the obviously like left min equals 0. To be honest, I don't. Also, I don't get this probably. I also don't get this. Why though? You know. Um, Yeah, to be honest, I don't get this problem fully. I don't like fully understand this problem, and I'm just gonna like from now on, I'm just gonna solve. I'm just gonna get more ready for streams because right now I'm just very lost, and yeah, next streams will probably be better in quality, like because of me having worked more on the problems. But yeah, that's it. Basically, 2 hours probably spent on Leetcode today, which is not bad.